This is page 154, number 20. We have a triangular prism, which is a water trough. And the formula for the volume of a prism is the area of the base times the height of the prism. This is the height of the prism if it was standing on one of its parallel bases, the triangles. And this is the base of the prism, which is a triangle. So it says that the length of this trough, which is this, is 12. And I'm going to call this length so that it doesn't get confused with the height of the triangle on the end. Now the area of the triangle on the end would be 1/2 times the base times the height of the triangle on the end. And since when it's all the way full, the base is 3 and the height is 3, then when it's filling with water, it would create a similar triangle with a base of B and a height of H, but the base and the height would be the same, just like the 3 and the 3 are the same. So B is equal to H. Now, if anything is ever a constant, you can replace it before you take the derivative, and that length is always going to be 12. The base and the height aren't always the same because you're filling it with water. So I'm going to take the volume of the capital B is 1/2 times the base times the height, which is the little triangle, and the L is 12. And since B is equal to H, then I can replace the B with H, since the question asks about how fast is the height changing. So volume is 1/2 B squared times 12, which would actually just be 6H squared. Now I'll take the derivative with respect to time. And plug in the values. In part A, it says it's filling at 2 cubic feet per minute. And we want the height to be 1. And what is dH over dt? So dH over dt would be 1/6 feet per minute. Part B says that dH over dt is 3/8 inches per minute. And H is 2. So taking this formula again, this time we're looking for dV over dt. It would be 12. The height is 2. And the dH over dt is 3/8. This must be feet. Sorry, I didn't have my book. And that would end up being 9 cubic feet per minute.